All right, let's dive into the secret world of our smart devices. You probably think everything just, connects to the internet, but the reality is so much smarter and more fascinating than that. Get ready for this number. By the end of this decade, we're looking at nearly 29 billion smart devices connected online. That's a massive global network of everything from giant industrial sensors in cars to the little smart gadgets scattered all over our homes. But here's the thing, these devices are nothing like your phone or your laptop. We're talking about tiny gadgets that often have to survive for months or even years on a single small battery. They might have spotty, unreliable connections, and honestly, they only need to whisper tiny little bits of information, like a single temperature reading. So that creates this huge communication puzzle, right? How in the world do you get billions of these tiny, low-power devices to speak a common, efficient language without just completely draining their batteries or clogging up the networks? Now, your first thought might be, hey, why don't we just use the language of the web, HTTP, to solve this? It makes sense on the surface, but it turns out that's a surprisingly terrible fit for the Internet of Things. You use HTTP every single day. It's what your web browser uses to fetch websites. It's a really powerful protocol, for sure, but it was designed for powerful computers with stable, fast connections. Its whole world is based on a simple ask and you shall receive model, which is perfect for downloading big websites and files. But here's the killer problem. HTTP is, well, it's chatty. A lot. The headers on its messages, just the address label essentially, can be over 800 bytes long. Now imagine your little smart sensor only needs to send a 2-byte temperature reading. Using HTTP is like sending a massive, heavy shipping crate just to deliver a single grain of rice. It is wildly inefficient. And all of that extra chatter, all that overhead, it comes at a huge cost. Battery life. Every extra byte means the device's little radio has to work harder. In fact, tests have shown that using a chatty protocol like HTTP can drain a device's battery up to 30% faster than a more streamlined one. This table just lays it all out so clearly. You can see the total mismatch. HTTP is built for a device to actively pull big chunks of data, like a web page. The world of IoT, though, it needs devices to just efficiently push tiny, constant updates out into the world. They are fundamentally designed for opposite jobs. So, if HTTP is the wrong tool for the job, what's the right one? Well, the industry came up with a solution, a protocol designed from the ground up for these exact challenges, and it's called MQTT. Now, MQTT has some seriously rugged roots. It was created way back in 1999 to monitor oil pipelines over choppy satellite connections. So it was engineered from day one for one thing and one thing only: sending messages reliably with the absolute minimum of resources. Its fixed header, just 2 bytes, that's it. And instead of that direct one-to-one conversation like HTTP, MQTT uses this brilliant model called publish-subscribe. The best way to think about it is like a central post office, or maybe a switchboard operator. In the MQTT world, this is called the broker. This right here is the absolute key. A sensor doesn't need to know the address of the specific app that needs its data. Nope, it just publishes its temperature reading to a topic. Think of it like a channel named something like living room/temperature. Then any other device or app that cares about that info simply subscribes to that topic on the broker, and boom, it gets the updates instantly. So it's super efficient, but what makes it so trusted for really critical stuff, from connected cars to hospitals? Well, it's because reliability is baked right into its DNA. It actually offers different levels of what it calls quality of service. The basic level is QoS 0. It's pure fire and forget. It's just like sending a postcard. Super fast, super efficient, but hey, if it gets lost in the mail, it's gone. This is perfect for non-critical data, where a missed reading here and there isn't the end of the world. Then you have QoS 1. This is more like sending a registered letter. The sender keeps sending the message over and over until it gets a receipt confirming delivery. This guarantees the message will arrive at least once. It's actually the most common level used because it ensures important data gets through. And then for the absolutely mission-critical commands, I'm talking financial transactions, commands to a factory robot, where you cannot, under any circumstances, have a duplicate message, there's QoS 2. It uses a secure 4-part handshake to make absolutely certain the message arrives exactly one time, no more, no less. So this unique blend of being super lightweight and also incredibly reliable has made MQTT the invisible backbone of our modern connected world. And once you know what it is, you start seeing it everywhere. It's in precision farming, helping monitor soil to save water. It's in your car, sending real-time data back to the manufacturer. It's the reason the lights in your smart home turn on instantly. And in hospitals, it's reliably transmitting vital signs from patient monitors, second by second. And look at this. This shows the real, tangible impact of using the right language for the job. We are talking about major results here. A 30% drop in water usage on farms, a 25% jump in factory efficiency, and a huge reduction in equipment downtime, all because critical data can be shared reliably and in real time. You know, this quote from a construction safety manager in Hong Kong just says it all. It's not just about data. This technology fundamentally shifts how teams work. They go from just reacting to problems after they happen to proactively preventing them, all because they get the information they need right when they need it. Okay, so let's pull all this together. At the end of the day, it's a messaging protocol. Why does this simple, tiny language matter so much for where we're all headed? Well, it's because MQTT isn't just a protocol anymore. It's becoming the essential nervous system for this coming era of what people are calling physical AI. That's the technology that lets our physical world, our buildings, our cars, our farms, sense what's happening, communicate, and react intelligently, all on its own. This technology is the literal foundation that's going to let our environment talk to us, and maybe more importantly, talk to itself. It's the language that will let your car talk to the traffic lights and the farm talk to the weather forecast. And that leaves us with a pretty fascinating question to think about, doesn't it?